Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. Today we would be discussing section 2.2, errors in data transmission or errors in data communication. Errors in transmission. During transmission, there is always a risk of data corruption, data gain, or data loss. These errors can occur during transmission due to either interference, means when the signals are traveling on a cable, then there is always a chance that if there is another cable nearby, so due to induced electricity or due to the other cables also carrying electric signal and their magnetic field or induction field, some current can sweep into the cable that is carrying the data signals, and because of that you can get electrical interference or noise, and as a result your data can be corrupted or it can even be lost. You might have noticed on a stormy weather, when you call somebody, sometimes there is a lot of noise in the background because of this, because the signals are traveling in the air and in the atmosphere there is also lightning on a stormy weather, so because of that the signals gets disturbed and it causes noise in the background. Next, lost packets in data or packet switching. We have studied about packet hopping. Now let's suppose a system is not following a hop number and the packet just keep on roaming from here to there endlessly. It might get delivered to a destination in between of another transmission. So what would happen? It would be added into the new transmission and thus the actual message would be corrupted. For example, a packet was just roaming here and there. It was a lost packet inside a network. Now after a few days or a few hours or some time later, another transmission occurred and this packet somehow got mixed up with that transmission and was delivered to the new transmission's destination. Now this would add an extra packet to the ongoing transmission. Thus it can cause data loss or data gain, means some additional data has been included or added into the transmission. Last but not the least, another reason for error can be skewing of data, which happens in parallel data transmission. We have discussed that when you are sending data over multiple lines, so sometimes the order in which you send the bits, or basically the number of bits which are sent together, they don't always reach their destination at the same time and sometimes they are out of sync. This can cause data corruption as bits arrive out of synchronization. Number fourth bit arrives before the second at second place and number second and third bit arrives after that, so it alters the message. You sent 1011 and over there it is received at 1101, so the message is totally opposite of what was intended. Now there are some methods to detect if there have been any error during the transmission, and the first of those method is a parity check. What happens inside a parity check is that all the ones in bit stream are counted. There are two possible systems in parity check: odd parity and even parity. In odd parity, the bit stream must have an odd number of 1 bits, while in even parity the total number of 1 bits should be even. Parity bit is transmitted before the bit stream. For example, here is a bit stream from here till here, and if it is following odd parity, so 1 2 3 4, these are even number of ones, so we will just add 1 as the parity bit to make it odd. 1 2 3 4 5, now it is odd. And if it is even parity, 1 2 3 4, it is already, there are even number of ones, so we simply add a 0. 1 is added as parity bit to make the total number of ones in a bit stream odd, and 0 is added in this example as number of 1 bits were already even in the bit string. Now this type of parity check is best to detect if only one bit has been switched or changed during transmission, or if there is only a single bit error. Parity check is not successful if two or more bits are altered during transmission, which is known as a burst error. Hence 2D parity is used. It is an advanced form of parity check which is known as 2D or two-dimensional parity. A parity byte marks the end of transmission. In 2D parity, parity of each row and column is calculated and sent along the message. The row containing parities of all the columns is the parity byte. Each row and column is checked respectively. The row with a parity bit mismatch and next the column with a parity bit error marks the location of bit that has been altered during transmission. See, you get a parity block like this, okay, 1 byte, 2 byte, 3 byte, 4 byte, and at the end there is a parity byte, which is basically the parity for all of these columns. Now 2D parity can catch 1 bit, 2 bit, 3 bit, and at most 4 bit errors. Now examiner in the question paper is going to give you this block, and he is going to tell you that the system follows even parity or odd parity, like it's written over here that it follows even parity. So first of all we check all the rows, 1, 2, 3, 4. This is correct. 1, 2, 3, 4, 5, 6. Again it is an even number, so this is correct. 1, 2, even number, correct. 1, 2, 3, 4, 5. This is wrong. So what we do is we either shade this row or we either put a circle around it, like I've already put a circle around it. And then 1, 2, 3, 4. This is also even. This is correct. Now we check each row. 1, 2. This is correct. 1, 2, 3, 4. Correct. 1, 2. Correct. 1, 2, 3, 4. Correct. 1. This is wrong. Hence I have circled it. 1, 2, 3, 4. Again correct. 1, 2. Again correct. 1, 2. Correct. Now the point at which these both shadings or these both circles intersect is the point where means this one. This is the point, or this is the bit which has been altered during transmission. Means when, so how you write this? Byte 4 is the one which have error, and column 5 also has error, and the point at which they both intersect, that bit is wrong. Means instead of, if this is a 0, this it should be a 1, and if there was a 1, then the intersection would mean that over here 1 should not come but a 0 should come. So if you are asked to write the corrected bit, you are going to start from here. You will write this whole row, but you will change the intersection, like 1 1 1. This is 0 0 1 0 1, so we corrected it to 1 1 1 0, and we change this 0 into a 1, and rest of the line stays the same, 1 0 1. This is how you find a correct bit from a parity block. This table is known as a parity block. The next method which we have is automatic repeat request, or ARQ. Data to be sent is broken down into small packets. After sending each packet, the sender waits for an acknowledgement from the receiver. Now over here the word acknowledgement is the keyword. You must have to include it. Now there are two types of acknowledgement. One is known as the positive acknowledgement, one is known as the negative or no acknowledgement. What is a positive acknowledgement? That you sent a message and you received a short reply, I have received your message. And what is a negative acknowledgement? That you sent a message but either you did not receive a message, or either you receive a message that the packet you sent had errors, so I am discarding it. They are both type of negative acknowledgement. An acknowledgement is a message stating data has been received correctly. If an acknowledgement is not received within a certain amount of time, the same packet is resent, and this is the second keyword for this automatic repeat request. If acknowledgement is not received within a certain amount of time, the same packet is resent. Let's understand it with an example, with a little diagram. You don't have to draw this diagram in the paper. This diagram is just here to understand. Now the sender received a packet, and the receiver checks it either through parity or whatever method, and if it is correct, then he sends an acknowledgement that okay, I've received your message. If the acknowledgement, see over here, it's timeout, the acknowledgement reaches the sender after the ending of the time. So in this, instead of sending the other packet, the same packet is resent. Packet 1 expected, discard, acknowledgement, resent. Now this had already received packet 0. It was expecting packet 1, but it again received packet 0. So it has resent, it has discarded the package that I already have it, and it has sent an acknowledgement again that I already have this packet, send the next one. Now this time the sender received the acknowledgement within time, so he has sent the next packet, and which is delivered, and the next acknowledgement is sent. Now if by any chance the acknowledgement is lost during transmission, then the same packet is resent unless and until the sender receives an acknowledgement about this packet. The next method is error checking method, echo check. In echo check, when a sender sends a packet of data, receiver sends back a copy of same data or same packet. This is the first keyword. The sender compares the two packets. This is the second keyword of data to conclude whether there is any error present or not. The sender sent a packet, the receiver resends the same packet back instead of an acknowledgement. Now it's the job of the sender to compare the two copies and find if there has been any differences between the two copies or not. If there is no difference, then the next packet is sent, otherwise the same packet is resent. This is sort of an obsolete method now because it takes up a lot of resources for the internet. The whole packet keeps on moving forward and backward. The next method we have is checksum. What happens in checksum is that before transmission of a data block, its checksum is calculated and sent along with the data. The receiver recalculates the checksum and compares it with the checksum sent along with the data. If the two checksum matches, data is assumed to be received error free. Now how do you calculate checksum? In the question you would always be given the byte sum or the sum of the bytes. So if the sum of the bytes in the packet is 255 or less, then the checksum contains the exact value. Means if it is 115, 128, 254, then that value is said to be the checksum. But if the sum of other bytes is more than 255, then the checksum is the remainder of total value after it has been divided by 256. For example, we have over here two examples. Byte total is 1151, and in second example byte total is 115. Now since it is less than 255, so we would say we don't need any further calculation. We would simply say that this number is the checksum. Whereas over here, since it is greater than 256, then we would divide this by 256, and we are going to get, and what we get, 4.496. Now round it off and multiply it with 256. You get 1024 minus this number which you just got, and minus it from the original number given in the question, and whatever is the answer is your checksum. Or if you want to go with a shortcut, then let me show you. Simply what you need to do is just divide the number 1151 with 256. 4 the 1024, and the remainder is 127, which is our answer. The next method which we have, and the last, is check digit. A check digit is a digit added to the rightmost position in the code, and it is calculated using all other digits in the stream. Now, how do we calculate check digit? This is mostly used in the ISBN numbers of your books. Add all the odd numbered digits together, excluding the check digit. Add all the even numbered digits together and multiply by 3. Add both sums together and divide by 10. If remainder is 0, check digit is 0, else subtract the remainder from 10 and resultant is the check digit. Let's have a look at the example. For example, this number is given to you and a dash is given to you in order to fill the check digit over here. So what you need to do is, you see, this is the first number, this is second, this is third, this is fourth, this is fifth, sixth, seventh, 8th, 9th, 10, 11, 12. Now what we need to do is, we need to add all of the numbers which are at odd places. Means this is the first number, 1 is odd, this is the second number, we don't need it, this is the third number, this is again odd, 3 is odd, then 5th, then 7th, then 9th, and then 11th. We just add all these numbers together, like 9 plus 8 plus 4 plus 9 plus 3 plus 6. For your understanding, I have given different colors to odd and even numbers, and we found a sum of all the odd position numbers. Then we add all the even position numbers together. For example, 7, 6, 0, 8, 2, 9. Now you would say, how are they odd? 7 is how are they even? 7 is not even. 7 is not an even number, but it is at the even position. It is at the second position, and second or 2 is an even number. We add them together and multiply it with 3, so we get 96. Now we add both these sums, 39 plus 96, 135. In the next step, we divide it by 10, and the remainder is 13. Remainder is 5. 10 13s are 130, and remainder is 5. Now we minus it. Since this is not 0, we minus it from 10. 10 minus 5 gives us 5, and that is our check digit. So that means we would write here five. And I have simply added the answer in the blank. Now sometimes the examiner is going to give you a blank and ask you to calculate the check digit. Sometimes it is going to give you a number and it is going to ask you that confirm whether check digit is correct or not. You will go through the same method and see if your answer and the number at the rightmost position matches or not. The next thing in this chapter which we have is IP address, or the difference between IP address and MAC address. IP address is basically Internet Protocol address. IP address gives the location of the device on the internet, while MAC address is used to uniquely identify a device connected to the internet or a network. IP address is temporary, while MAC address is a permanent address which cannot be changed, or at least it cannot be changed by a non-expert user. You need to be very tech savvy. You need to be very much expert if you want to mess with your MAC address. Now there are a few terminologies which you should know. ISP stands for Internet Service Provider. It is any person or company that is providing you the internet service by taking a small monthly fees from you. The next thing you should know is there are two more terminologies. Okay, so the next two things which you should know is a web browser. It is a software used to navigate or open websites. What basically it does, it translates the website code that is written in HTML into a presentable website which the user can view and interact with. And a web page is basically a single page of a website, any website. Next we have is HTML, the hypertext markup language. You should know this full form. HTML is the language used to design or make websites, and there are two components of HTML, or it can be divided into two parts. One is the structure. The structure is the essential part of HTML code that forms up the basics of a website. And presentation is the code that is written to modify or enhance the appearance of the website, or to make it more attractive, to make it easier to navigate or read. For example, CSS and JavaScript. Now, sometimes the examiner asks you to gives you two pictures and asks, or gives you two pieces of code and asks you to identify between which one is the structure and which is the presentation. Now, an example of HTML is something like this. These are known. There would always be angular brackets. These means less than and greater than sign in a code that is written in HTML, or that is an essential part of HTML code, or the structure part would always have angular brackets, whereas the CSS or the presentation part is always going to have something like this, curly brackets. This is one of the basic methods of identifying which given code is HTML and or structure, and which given code is CSS or the presentation. Since the details of HTML tags and CSS script is not a part of our syllabus, so just remember this: the angular brackets and the curly brackets. These are the biggest identifications of, or the differences between, structure and presentation. I hope you have understood the lecture. Thank you. If you have any problems, feel free to ask me. Take care. Allah Hafiz.